Hello there. My name is Doug Rumbaugh, and this is the first episode in my series on how to use the command line, where we're going to talk about a variety of core concepts for using command lines. We'll be using Microsoft Command Prompt for this purpose, as it is readily available and fairly simple. You don't have to install Linux to start messing around on the command line, and in fact, I would posit that getting familiar with using a command line in a more familiar environment like Windows will make a potential future transition to Linux much easier if that's something that you're looking at doing. Learning how to use a command line is going to be very helpful for just about anybody who does anything significant on a computer. Even file management can be done more efficiently from the command line once you know what you're doing. But it's of particular interest for individuals looking to mess around with Linux or looking to learn how to program. I'm not going to spend a lot of time discussing what a command line is. I assume you have a vague idea of that. But in this episode, I want to talk about a number of vocabulary terms and high-level concepts of command lines. So we're not necessarily going to do much in the way of actual commands just yet. That's going to come next. Accompanying this video and all of these videos are text articles on my website, link in the video description. So feel free to open that up and skim through it as well. Particularly when we get to running big commands, it might be convenient to have that resource there to copy and paste out, or you can do a Control F on terms, things like that. So the video and the text article should complement each other rather nicely. To get started, let's launch Command Prompt. Now, if you don't already know how to do that, the easiest way to do it is just hold down the Windows key on your keyboard and press R. This is the hotkey that will launch the Run dialog, as you can see here. Yours probably won't have anything inside of it. This will allow you to execute any program you want by name. So the command prompt is called cmd.exe, cmd.exe. Type her in, hit enter, and up pops our command prompt window. Now, first core concept you got to understand about command line interfaces is that on desktop operating systems like Windows and Linux and things like that, you will most frequently be interacting with these command line environments by using two different programs. There's what's called the shell, and there's what's called the terminal emulator. The shell, in this case, is command prompt. The shell is the program which actually processes the commands. It describes the way you have to format the commands, what the commands are, what different characters mean, etc. You can think of the shell as the language that you're talking to your computer with. There are a variety of options. On Windows, you have access to two. You have Command Prompt and you have PowerShell. These are both by default. We're going to be using Command Prompt because it's a little bit simpler. If you're on something like Linux, you have access to a whole slew of options like Bash is the most common one. And you can actually install many of those Linux shells on Windows as well. It is possible to run Bash on Windows. And at the end of this video series, we are actually going to do that. However, for now, we're talking command prompt. In addition to the shell, though, there's a second program called a terminal emulator. And the terminal emulator is the actual window that you are looking at. So, interestingly enough, both this command prompt window here and this PowerShell window here are running the same terminal emulator. It's something called Windows Console. So what you're looking at is actually the same program. There's just a different shell running inside of it. The terminal emulator controls the formatting of what you see, the text. It also facilitates interactions between the shell and you. So the terminal emulator will store the commands that you type until you're ready to send them to the shell. The terminal emulator will display the results of the commands, things like that. I'm going to go ahead and get rid of PowerShell here. And just as an example, I'm going to make my font size on the command prompt a lot larger so you have an easier time seeing it. This is a terminal emulator thing. Obviously, the shell itself doesn't care what the font size is, or for that matter, what the font is. So if we want to edit the way that the text looks on our terminal emulator, we pop open the Properties window, just right-click on the title bar, go to Properties, and here's where we can control what our command prompt looks like. So we have a variety of different options. You can click through this. I'm not going to go into it in detail. You can change the colors, etc. I'm going to go ahead and take the font size all the way up to 45, which is going to make the window a lot bigger. And I can, of course, just resize that. And now you should have a slightly easier time seeing what I am typing. The terminal emulator program also contains within it what are called buffers. Now, buffer is a word we're going to see quite a bit, especially if you're looking into programming. Buffers are quite important, and all that a buffer is a temporary holding area for some data. So when you have data on a computer, it's usually stored in something called a buffer. We have two buffers that are part of this Windows console terminal emulator. We have what's called an output buffer, also sometimes called a screen buffer, which contains the text that we see right now. It contains the text on the screen. And there is also an input buffer, which is a temporary holding area for our commands. So we plug in our command, and it's stored in the input buffer until we're ready to actually send it to the shell, send it to command prompt. When we open up a command prompt window, what happens is the shell itself writes this text to the output buffer of the terminal emulator, which is what we see. So this stuff isn't super important. That always gets written at the beginning, and we won't see much of that again. This text right here is what's called a prompt. Yours will perhaps have a different username here. It'll be whatever your username is. And the prompt is a sequence of characters that the shell writes to the output buffer of the terminal emulator when it is ready to accept a new command. So if we see this with our input cursor flashing right beside it, that is an indication that we are now able to enter a command and that the command prompt will be ready to accept it. So you type a command by just typing text onto the terminal window. Go ahead and type some gibberish here. Doesn't much matter. The text that we see here, well, we see it, so that would imply that it's in the output buffer. But more importantly, what we're looking at here, the text between the prompt and the cursor right here, is a copy of the text that's in our input buffer. So it's important to note that this is in a buffer. It has not actually been sent to the shell just yet. You send it to the shell by hitting the enter key. So once I type some gibberish, I can hit enter, and that will send it to the shell. The shell will process it, and then the shell will write some more text back to the output buffer, either representing the output of the program or an error message or whatever the case may be. Here you can see we get an error message saying that the shell can't interpret the command. It doesn't know what it doesn't know what the program I just asked it to run is. So we get that, and then it prints another prompt letting us know that we are ready for the next command. Now, the power of the buffer is that it allows us to edit the command before we actually send it. So for example, I can use the left and right arrow keys here to move the cursor around inside the contents of my buffer. I can only move it across characters that are in the input buffer, by the way. As you can see, I can't take it into the prompt itself, so we're trapped right in here. And I can edit text, inserting it into the buffer in the middle of it. I can also use backspace to delete to do that sort of thing. Now, one thing you'll note is that the up and down arrow keys, the down arrow key is going to do nothing right now, and the up arrow key is going to actually recall the last buffer that I sent to the shell. This is what's called command history. So the up and down arrow keys are used to navigate previous versions of the buffer that I sent to the shell, useful for running the same command multiple times with slight modifications, say. Another thing to bear in mind is if I type a lot of characters into this, you'll notice that the text wraps around down here. Now, this is what's called a soft wrap or a soft break or a soft return or whatever. As you can see, if I make the window bigger, that breakpoint shifts. If I make it smaller, it shifts. This is not actually a new line character in the input buffer. There's no indication in the input buffer itself that there's a line break going on right here. This is simply a visual thing. This is simply a visual thing. Now, perhaps confusingly for someone who's used to working in, say, Notepad or Word or whatever, if I want to get my cursor from where it is up to, say, this D, I need to navigate there using left and right. Because remember, up and down is for traversing history. So if I hit the up arrow key, rather than the cursor moving to that D, I'm going to lose my command, and it's going to go back to the previous command in the command history. Be careful of that. So that's your basic idea with these input buffers, output buffers, etc. Execute a command by typing it into the input buffer and hitting enter. And again, I just typed gibberish, so we just get gibberish. There's a few other things you need to know about interacting with this thing, though, before we can really dive into doing some real commands in earnest. We need to talk a little bit about control sequences, which are a second way of interacting with the shell. So we can interact with the shell by typing a command into the input buffer and sending it, or using control sequences. As an example of where this comes up, there is a variety of commands which will not relinquish control of the shell back to you immediately or even automatically. For example, sort. We'll talk a lot more about sort later, but sort is actually a valid command. It does something. And if I run the sort command, what you will notice is that the line, it goes down to the next line, but I don't get a prompt. The sort command did not release control. The shell is not ready to accept a new command. We're stuck in sort, as the case might be. So anything that I type in here, the input buffering is going to work the same way. It's on the input buffer, and then there I just sent it. But it's not being interpreted as a command. It's actually being interpreted as input to the sort program. So if I want to get back control of my shell from a program like this, what I have to do is use one of these control sequences. Now there are two that are particularly useful right now for reclaiming control from a program. There's the keyboard interrupt and there's the end of file. We'll do keyboard interrupt first because that's the simpler of the two. The basic idea here is you want to hold down the control key. All control sequences are initiated by holding down the control key and then strike the C key on your keyboard. So control C. And that is going to, as you can see there, that is going to get us back control of our program. And you can actually see that some extra stuff got written here to the output buffer as well. That's the output of the sort program. Now you'll notice that when I said control C, I got this character here. I have a caret or circumflex and then the letter C. This is your conventional notation for a control sequence. So the caret here represents the control key. It says hold down control, and then C is the key that you strike to initiate the sequence, or to finalize the sequence, I suppose. So control C. This is what's called the keyboard interrupt. And the keyboard interrupt is going to abort the running program. As you can see here with sort, it didn't outright kill it. It gave sort the opportunity to display the output properly first. Incidentally, in case you're wondering, what sort does is it sorts the input. So you can see the output lines here are just these input lines put in alphabetical order. Go figure. We'll talk a lot more about that later. But that's not always going to be the case. The Control-C is not always going to cleanly cut off the program like that. So the quote-unquote correct way to terminate a program like sort, which is expecting input, is going to be to send it what's called the EOF marker, end of file. EOF is short for end of file, and it means it's the end of the data. So I'm going to go ahead and run sort again. And we'll just throw in some random letters as input here just to make the point. Now, EOF on Windows is Control-Z. So you can see we have Control-Z. Now, unlike the keyboard interrupt here, which interrupts the program, when I type Control-Z for end of file, it actually writes a character to my input buffer. So this Control-Z is a character sitting in my input buffer. It can be a little bit confusing when you're working with some of these things because although there are two actual symbols used to represent this character, the caret and then the Z, this is just one character, just EOF. It's one thing. It just happens to be represented using two letters. Now that that's sitting on the input buffer, if I send it to my shell by hitting enter, that is going to result in the shell receiving it, getting the end of file, and then finishing out the program. So as you can see, Control-Z, enter, and then it displayed my output sorted as it should. So those are your basic control sequences. You have end of file, you have keyboard interrupt. Keyboard interrupt is useful for ending pretty much any program. It's analogous to closing it out in Task Manager, say. And then end of file is used to cleanly exit programs that are expecting input data. I would first try end of file, see if that does the job. If that won't shut the program down, then use Control-C. End of file is contingent on the program expecting an end of file. Control-C should kill most anything. Sometimes a particularly stuck program, that won't do it, but most of the time it will. And of course, your other option is if you have a program running on the command line and you just can't get rid of it, you also could always just exit out of the shell. And when you close the command prompt window, that is going to close any programs that are running inside of it as well. All right, so we've covered a lot of basic concepts and terminology here. In the next video, we're going to talk about some actual commands, actually get cracking doing some things. But again, just as a very quick review, when we're working with the command line, we have got two separate programs that we're interacting with. We have the terminal emulator, which is the window that we're looking at. It handles getting our input, displaying output, things like that. And then we have the shell, which is the piece of software that actually processes those inputs. The terminal emulator has two buffers, an input and an output. The output buffer is simply the stuff shown on screen. The input buffer stores our command prior to us striking the enter key and sending that command to the shell. When a command is sent to the shell is going to interpret the command, execute it as necessary, and then the output from the shell will get written to the output buffer of the terminal, causing it to display on the window. In addition to communicating with the shell via commands, typing stuff into the terminal emulator, we can also use control sequences, of which we discussed two. We have Control-C, which is going to immediately abort any running program. And we have Control-Z, which we have to hold down Control, type Z, and then strike the enter key, which is going to tell a running program that there's we're at end of file. There's no more data incoming. Depending on the situation in the program, Control C will usually work, but Control Z is the correct way, I'm doing air quotes, the correct way to terminate a program that is actually expecting input. And of course, this comes up in the context of this sort program here, because when I run the program takes over, if you will, the shell. The program's running inside of the shell, and until the program is done, the shell can't accept a new command, as indicated by the fact that it did not write a prompt. No prompt means that you're not working with the shell, you're working with a program running inside of the shell. And when I kill that program, I get my prompt back, and the shell is ready to accept a new command. So those are some of the core basic ideas of command line. In the next video, we're going to take a look at some simple commands that we can start using, something a little more useful than sort, for manipulating files and things like that. So I hope that you found this interesting, and I will see you over in that video.